Welcome to Turn Right Machine Works. My name is Keith, and this is part 2 of the restoration of the bell yoke and cradles. And today we have the cradles, and the first thing we're going to do is we're going to get into taking and needle gunning these ends right here so we can take off the top cap here. Now these fasteners are old square style fasteners. Things been together forever. And this has, some places a 1/4 inch of paint, and we're going to go ahead and use our needle gun to go ahead and remove that paint. Now, I call it a needle gun, and there's a lot of other names for it, rattle gun and scaler and a couple other things. I call it a needle gun, and most people that I know that have had them in the past call them needle gun because of the needle shape rods that it has in here. And this happens to be a straight in line, but there are some that have like a pistol grip type of holding shape to the gun itself. I like these because they with them being long, that you can get them down into small areas like that. Also with the needles, eventually they do break and come loose, and sometimes you put in a new set. Needles also come into play where you might find one that's at a halfway decent length and it still has a little head on the end there. You can grind a shape or point on the end and use it as a center punch. You can keep it blunt on the side, and you can use it as an 1/8 inch drip punch. So that, that's taking a broken tool and making it into another useful tool. Just an idea. But the tool itself is a great tool for removing paint, removing flakes of rust, and also I use it to go ahead and scale the slag off of welds. It saves from beating, and it really does. Sometimes when you're welding and your first pass, or that root pass that is trapped down within itself, that flux is on there rock hard. And these scalers actually, or the needle gun, do let you get that slag out of those tight pockets and everything. So it's an all-around tool, and I use it just about everywhere in the trade. So anyway, I'm going to go ahead and I'm just doing this in here because we're going to be cleaning up and sweeping up the floor. Some of this is old paint. I don't want it out in the ground and go into the water table or anything else like that. This flakes it off, so there's not a whole lot of dust and stuff like that, so I'm not going to wear an air mask or anything else like that. Alright, and the reason why I got the post out here, I don't want to be down on my hands and knees, and I can have this up here and be comfortable and stand here and go ahead and knock out some of this rust. Alright, now we're going to go ahead and do the top side. Really does expose the whole head of here, but you also can start seeing the split line around here where this thing mounts. And that hole is already, this is pretty big hole. Okay. Alright, here's these two. Alright. Here's the two side by side. Alright, here's the one we just needle gunned, and you can see how big that port is. Alright, this is how it looked before it was needle gunned. That almost looks like tap size hole for an 1/8 inch pipe fitting. So there was plenty of, that probably had a press-in oil cap. Same thing in that one, same exact size. Okay, first thing we do is we're gonna just lightly cinch this down the table so that we can grab these. And what we want to do is we want to try to get these square head bolts out of here without breaking them. And if we can do that without putting any heat or anything else, that'd be fantastic. We can wire wheel them and put them back, you know, they can be put back in here on the assembly. But we're going to go ahead and we're going to grab some hex head bolts to where we can use wrenches and put this thing back together after we go ahead and clean out this split line. And these square ones will be put back in place to keep it original. And you got something this old, you just want to respect where it's from. See if we can get lucky 3 more times here. You know, it's funny is that, you know, even as bad as lead paint and everything else is supposed to be bad for us and everything else, you know what, it did one hell of a job. Alright, and we're going to go get a mallet, and we're also going to match mark these before we lose them, so we're going to put a little prick punch here and there. We'll go ahead and we'll punch this one first in case it breaks loose, and we'll hold it so it doesn't drop, and we'll put a single punch here to match it. So it is pretty solid in there. Alright, we got our rawhide here, and we're going to break it loose. We'll get that dirt and everything else out of there, but that really, we'll clean all that up and we'll clean this up here. Alright, let's get the second one up here and we'll get it apart, and we're going to mark it with 2 and 2. Alright, here's the second one here, and same thing, kind of easy after you get the initial breakthrough here. It's amazing the threads and stuff are still pretty good on these bolts. That's probably the roughest one right there, but it still has good enough threads to reuse that. And we're going to go ahead and break this one loose now. Okay, and we said we were going to punch this one with 2. That is a nice snug register there. They are able to pop in and out. Alright, so we're going to get a little cleanup in here. We do have to make sure that these are metal to metal, because after we get done, this thing is going to be bead blasted, and we want to make sure that when these things are located that we have true round holes and bores. Alright, we're going to set this up on the Bridgeport mill here. We're going to block it up off of the surface right here. But this underside surface that's down against the table, we've already needle gunned this one here, but we got to go over, we're going to needle gun the second one there. because the paint buildup was so big, and even just having a casting, it has a little bit of rock and everything, but it's going to be the surface that we're going to judge the overall flatness or 90-degree to the vertical legs to do this bore here. Alright, see, we got some of this paint off of here, but this paint is pretty thick, and I mean even some of this down in here, the span right here and across here is a totally flat surface, and this hole is 90 degrees in relationship to that. So we're just knocking the paint off, and then we're going to take the second cut file, come across it, just make sure that we don't have any paint holding this up off the table. Okay, we got a couple spacer parallels, 3/4 by 1.25 or so underneath this cross section here, and a bolt here, and one sitting underneath here. So we're level and we're flat to the table. We got this set. We got our regular tap follower, but it's got a nice point on it, and it runs pretty true, and I like it. And we're just using it to go ahead and come up here. We're going to put our scale in line with that split line, and we're going to come in center of our register right here, and we're going to pick a 0 spot for our location on our hole. We do know that we want to be equal to the split line up and down, and then we're going to clean it until we're round and to a diameter that's comfortable for a sleeve diameter. Alright, so let's bring it on up. Alright, and all the way across here from outside to outside looks like 5 inch. That's pretty good measurement there. And center to center on this little register that's in here, that's almost 4 inches exactly. Alright, in line there. So we'll go ahead and we'll bring this in to about the 2. Bring this on over to the split itself. The light's much better on the scale that way for me, and seeing the lines there, and I like that. Alright, we're going to call that 0, and we'll set our readout in both positions to 0. Alright, we're going to change this out for our boring bar. We're going to need some clearance in here now. Alright, and we got this kind of in neutral here, and we're going to go ahead and pull this bit out of here, because we're going to run a carbide bit on here. This is the one we used on that aluminum cutting for the, and we want to make sure that we're going to be long enough here. Okay, we're long enough there. Alright, we'll get our Allen wrench for that, and we're going to size up. That carbide's a little big. Alright, this little bit, we'll be able to run this little bit in here and have it hanging out. Like so. And we're kind of looking at our rotation here. We'll angle that back just a little bit. and we know the wear's down here. We can see that we're almost 20 thousandths or so, and we're just tiny bit off of the split line as far as being across here. We're going to go ahead and we're going to do this. We're going to double check from here to the split line on both sides here. Alright, that's about 1 inch 450, and we're 1 inch 450. We're pretty darn close. Okay, I'm going to call that a good place to start there. Now, this is cast. We're going to go ahead and we're going to put a rag underneath here so that we can catch most of the powder from the cast. And we're going to slow her down a little bit until we get the feel of it. Right there, that's about 135 RPMs. Alright, now the next thing we want to double check is actually what is our max that we're going to be taking here. That looks pretty good. I think we're going to be safe. We just want, you always want the gib, you want to at least snug. You don't want to leave your gib loose there when you're cutting. Sometimes it has a tendency to vibrate. And now we're going to go ahead and we're going to set up our feeds here. Okay, let's see if I can kill a couple different subjects here. Time to time I get asked to explain different things, and one of the things that I see now I'm in this area, I've had an inquiring on how this travel dial mounts up and operates and how I like it, and we'll just touch bases on that. This bracket right here that actually holds this travel dial was made by Travel Dial for the Bridgeport. And basically it holds a slide that controls this piece of key stock up and down, and the piece of key stock travels with the quill. When the quill comes up and down, it creates the motion on the dial by pushing up and down and holding itself against the foot or the wheel of the travel dial. So that's a view from this side here. At the same time, we're getting ready to engage our feed for this. And this is your in and out engagement for spindle feed, and you're supposed to do this before engage and disengage your feed manually by hand. Don't do it while you're running. You just don't want to be grinding gears or across a gear tooth or whatever. You need to turn this with it manually just by rotating it around. If it doesn't want to go from one to the other, slightly roll your spindle in one direction or another, and you'll get that to pop in. Alright, now let's come around to the front and we'll kind of look at a different angle of this travel dial and go to the next feature of engaging the feed. Now here's a close-up of the face here, and this is just like the travel dials on the lathe here, and the up and down and this key stock here. You can see the key stock sticks way up here and then protrudes down past here when it gets down to a certain level. But your quill and your spindle are down below here before the starting spot as well. Most of the time this key protruding down past the bottom here does not interfere with your parts or your machining going on. Alright, and here you can see that you've got the two bolts, the top one and the bottom one right here. You can see that this is your regular quill stop, and it has a joint that goes over here and has a screw that goes in the end there that joins that key stock. But it operates the same as most of those digital styles, the same thing. This bracket and housing is just a little bit bigger, and it was made specially for the travel dial. Alright, we're coming over here to this side, and this is your actual feed choices for your spindle going up and down, and you have 6 and 3 stamped by these two pins here, openings, and you also turn this as you rotate it around, and you have 1.5 over here. So the fine is in the middle, 1.5 thousandths per revolution, I believe, is what it is, and this would be 3 thousandths per revolution and 6 thousandths per revolution. I believe that is the gauge of feet. If it's, well, I'm going to say I believe that that's what it is. In my relationship to, or in my experience on boring, the feed rate of the bore looks just about like that. Now, to engage the feed, you have a couple different sections of the feed for travel and engagement. The travel is this little knob in the middle of the hand wheel, and that's pulling it out is one direction and pushing it in is another direction, and slipped right in the middle is a neutral. It won't be turning it. All right, and that helps also to go ahead and rotate the handle as you're going in. Here's that middle section, and then there's pushed in. All right, so that works a lot better by doing it without the thing running, and you can change it. Although you can actually have the spindle rotating, and you can wait for it to come all the way around, and it pops in there for you. But it is a lot easier just to grab the hand wheel and get to that position real fast. All right, now counterclockwise is up and clockwise is down. Now, to engage the actual spindle, even though this is running here, you can go ahead and pull that lever out, and then that will engage your spindle. And after all your backlash is taken up and all your linkages, it actually starts feeding it down. Now, if you have your stop set for this foot here, when it hits or bottoms out, it would trip this lever out. It's kind of under tension spring loaded, so it will automatically trip itself out. But that you can manually trip it like that and then raise it back up. Now, if you wanted to, you could have your engagement out up here for your whole total feed, and you can engage this and you can hand crank this, and it would manually hand crank your spindle up and down. Sometimes I do that for spot facing, and I'll show that in another episode. All right, let's go ahead and get a cut engaged, and I'll show you it actually in operation here. All right, I'm going to be standing by on this anyway, so I bring this down. First off, we get it cutting in the right direction. I had it turned on just to show you a demonstration there. All right, our knee, everything is locked solid here. We're at 0, and we'll make that 1/1000th of 0 also. All right, now we just come on down. We're starting to hit. We'll go ahead and engage it. And then as soon as the backlash comes out of the system, look at that, it makes me a liar. Oh, I did have it in the wrong direction. Okay. Clockwise is down. And all the backlash is out. And it's traveling down. Alright, this is the finished cut, and we're waiting on the bottom side down on this side over here at the very bottom. There was a slight little hollow, but it was a spiral that went curved somewhat around the bore. You see that little area right down at the very bottom? About 12 thousandths a side right here. Alright, this bore finished up right at 1 inch 311, or 1 inch 311 and a half. Very, very close to 1 5/16, and we're gonna call that finished. So we're gonna pull out our boring bar here, and we're gonna put back in I call it with our pointer so that we can quickly zero in on center line or split of the second part, and we'll go ahead and we'll throw that in. Alright, and we'll go ahead and get rid of this cast iron chips there. And lay our little cloth back down in here. We had almost forgot to file off the, pretty close. We'd almost forgot to file off the needle gun paint chunks. And last time we just eyeballed this center there, and that was good enough. And something like that. Bring the table up. Okay, we're going to call that 0, and we'll wait for the first skip of the cut coming around, kind of determine it from there, what that looks like. And we're really within 12 one way, not that it means anything on X, and on Y we're within 29 thousandths. So it's pretty much in the same location it was, the other one was, in relationship to the table, just by eyeball. Alright, we're going to lock her down and we're going to let her cut right there. See what she's doing. Okay, then go ahead and add a little bit more. Alright, this is a little slug of oilite or oil impregnated bearing stock or bushing stock. And we're going to go ahead and chuck up on this. Now, one thing, I do know that this is slightly bell mouthed on both sides. So we're going to semi-chuck it in the middle, leaving what we need sticking out here to go ahead and make one of the bearings, so that it doesn't rock. See, if we had this in here, it would be rocking if we held it out here to try to get two of them. So, and it doesn't matter which way we turn it. So I leave part of that other side hanging out and this side hanging out here. And you can see how that runs out anyway. So this is going to be turned here, and when we get ready to do the other end, we'll be holding it on a good section in the middle here, just like we are for this side here. And we're going to go ahead and we're just going to face it, turn it, drill it, and bore it so that it's 2/1000 press on the OD and 2/1000 clearance on the I. Okay, I'm already yawning. All right, so I'm I'm going to take and turn one of these insert over in the holder here. So we can speed some things up here. And we're going to be turning it in reverse, and we got to switch our feet as well, and our speed. All right, now we got to come up to center here. Alright, that's a lot better. And how close were we to center? Let's wipe the fuzz off of here. Pretty darn close. Alright, we're going to go ahead and center our drill out. Should be for our bushing here. Pretty soft stuff. Alright, we're going to get real close to the dimension of our shafts there. We're going to mic those up real quick. Get our 1 to 2 mic here so we can be fairly close, and it looks like we got about 250 or so to go. Getting down pretty close, and this is pretty simple turning, just ID, OD, and alright, we're at 332 and a half, 332 and a half. Alright, now we only need to go to, I'm going to snap both of these. Okay, one of those is 1 1 inch 312, and the other one is 1 inch 302. So we're going to go somewhere like 304 for one and 314 for the other. Alright, so we're going to shoot for the high one first, just so if we miss, we can second it for the smaller of the two. And we're at 332 here, and 18 repeated in 9. We are right at 314. We did good. I think well, we're a little bit warm here. I think we're going to call it good though, and we're going to polish the bore over there, so we should be able to close that down on that. Alright, so we're going to go ahead and we're going to part it off at let's see, do we want to bore it? If we bore it right now, we won't have to do anything else to it. $908 and $930 and $945. We're coming in, we're touching the bottom there so we can set our dial and we know where it is. Alright, we snap gauged it and we came up with about 4 thousandths over, and we're happy with that fit there. And we're good on the OD. The OD, now that it cooled down a little bit, we come up still about 314 or so. We're going to leave it that diameter right there, because we can put this in a small chuck and we can massage the OD down a couple thousandths if we want to. And we're going to part this off now at 1/900 long. Alright, now we can take it into our little south bin there and just kiss the chamfer on both inside and outside, both ends. Alright, we have finished both bushings. They'll need the oil hole and a keeper pinhole, and both of them we got about 2 thousandths clearance on them. Alright, and we got there's about 1.5 to 2 thousandths press fit to the housings there, and we're going to be checking those out. Now, while we were doing this, and we had a customer come in and pick up his job there, and then as he was leaving we had a mishap.